This is a recording for the AMPS Conference 2022, The Inverted Studio, Teaching Techniques for Online Design Studios. Hello, I'm Robert Brackett. I'm faculty at Pratt Institute in the School of Architecture, primarily teaching in undergraduate architecture, and I also serve as the co-director for the DRA lab. There with my partner, Koschitz, we focus on design research around pedagogy, geometry, materials and fabrication, and how all that feeds into the study of architecture. Dux and I have worked together on this research, and I'll be presenting for both of us. I'd also like to thank our research assistants, Noah Rosenberg and Daniel O, who helped bring together a lot of these assets from several studios and compile it into a presentation. The Inverted Studio was an idea to look at how we can teach architecture studios online without losing a lot of the interaction and visual reference to work and development that we have in in-person studios. What has come out of it is a guide that contains course structures, representational techniques, and methods of making, and some of the ways we put those all together to engage with remote students and help them excel in this online design studio with work that is comparable to anything that our students produce in person as well. This project originally started as a strategic initiative funded by the Office of the Provost at Pratt in fall of 2019. Our efforts shifted from the academic documentation of online learning and how to apply that to studios to hands-on experimentation when all of our studios went online in March of 2020. The methods within this guide were tested in multiple advanced design studios and intermediate architecture design studios, as well as in drawing and representation courses, seminars, and K-12 pre-college studio courses. This research project aspires to find novel teaching techniques for online design studios that significantly includes making at home. We don't want this to get lost from the design studio environment and the learning of how materials interact with the physical world. Inverting the design studio teaching model from an in-person to an online pedagogy provides an opportunity to create online learning models that serve a greater international and underserved population at the same level of quality as our current programs in person. How can we successfully move in-person design studio teaching to the online format? And if we can, what are the main issues to consider without compromising the quality? How can students engage in the process of making at home that is similar to making in the university context? And with the help of the Vice President of IT, Joseph Hemway, we were able to put together kits to help students make at home and test out consumer level of technology to replace some of the access to resources that you would have in the in-person context without having a significant budget expense for those online students. The COVID-19 pandemic, as I mentioned, kind of kicked this research into application rather than study, and it intensified the direction of that research to allow us to document what was working and quickly define methods for maintaining contact and production with students online. We subsequently developed an advanced design studio for summer 2020 and fall 2020 to refine the system for online learning and share it with the entire community at Pratt. And this has come together in a booklet that many pages are extracted from here, and we continue to incorporate a lot of this into our online, hybrid, and in-person studios as well. We see the primary contribution of this research is a relationship between online digital whiteboards for sharing work, the design of a visual course structure to help students understand the map and follow along at any time and have access to all resources, as well as the development of a making at home kit to help alleviate some of the costs and equipment loads, or just guide students in the direction of how they can make things in their home at the same level of quality as if they were in the institution. In the summer of 2020, we worked with Pratt's IT department, Joseph Hemway, to supply CNC paper cutters to each student in the advanced design studio. Students also worked with 3D printers that they already had, basic photography setups that they could cobble together out of materials and supplies available to them, and also readily available model making and drawing tools that they were all used to working with. This also works with an earlier first-year context, as it was tested out in some of our first-year representation courses. The techniques that follow support both digital and analog workflows and operate at many scales and in many mediums. Beyond the immediate context of the dramatic shift to online learning due to the global pandemic, we started this research to develop an interface for teaching design studios in the virtual format without losing the benefits of working with the physical materials in space. Our research focused primarily on architectural design studios, but we also see this as expanding to many other courses, including flat work representations such as drawing, painting, collage, and other three-dimensional fields like sculpture, industrial design, or interior design. We utilize a collaborative online whiteboarding application to bring the in-person studio space and the pinup wall into the virtual learning environment. Platforms such as Miro provide an open, flexible, and visual space for sharing multiple media sources. Students can upload drawings, model photography, AR and VR interactive models, videos, websites, and documents, and even put together their whole presentations and deliver them online via Zoom and share them as browsable maps. This expands upon what we can really do and share in person, and also consolidates many of the mediums into one defined space. This makes it a lot easier for students to communicate and share their work, as well as for faculty to engage with it, leave comments that persist, and keep things kind of live on the wall throughout the whole design process. A visual course structure can help in guiding students through the learning experience of a studio space by flattening the file-based hierarchy of traditional LMS platforms and keeping live all documents of the course progress. We established several templates for studio, seminar, and lecture-based courses that preference a structural learning space in a virtual format. By having the syllabus, assignments, resources, readings, discussions, research, and design work always present and always available in one space, students are able to have greater agency and access to this integrated learning environment than they ever even had in an in-person studio. And we now incorporate the use of this Miro template for our in-person studios so that we can oscillate between the different environments to help kind of push different aspects of how presentations come together in a more digital world. We established two primary learning environments for the online studio setup. The first is a work-in-progress environment, a design studio space that brings the messy, open, overlap, desk, and pinup space of an in-person design studio into the virtual platform. The second is the design review space, a curated, formalized space that is for presentations and external project review. You can think of these as the working, thinking, learning space and the presenting, sharing, discussing space. Specifically to the work-in-progress space, Miro boards facilitate the real-time working environment that is non-synchronous and informal. It is valuable that instructors and students can communicate on feedback related to ongoing tasks and development of design work and exercises in real time. Syllabus and assignments are noticed on the same Miro board, so they're always accessible and easily referenced, especially for schedule and the weekly timelines. That weekly schedule and timeline is also used as a resource to help structure the course so that students can see how progress is developing over the semester and know what's coming up next, rather than having to go to a secondary platform outside of their daily space to kind of keep track of where things are. We think it's very important that students can observe the flow of the course visually, and it also gives a nice structure for helping to keep everything in perspective and make adjustments when in the online format or in cases of something like the global pandemic, things may not always go as planned and can easily be adapted for everyone involved. All course resources like readings, tutorials, feedback, and things found along the way are accessible to students and faculty within that visual format. The virtual workspace combines the desk and the in-studio pinup wall into a fluid, multi-scalar platform. Work is easily referenceable and trackable over the course of a project, helping to guide the feedback and integration of the learning process. It is also valuable that work of all students is visible to each other so that they can develop communications and connections and share resources and references from within the studio itself. The virtual studio has the potential to greatly increase the collaborative sharing of design work within a studio, and we've used it in many of our team-based studios to really help facilitate how they build presentations, consensus, and track their decisions over time. Since conducting this research, we are continuing to use this format to structure studio-based courses for both online and in-person classes, since it creates a flatter, more open hierarchy that is adaptable to many course types and subjects. The presentation Miro space is formatted in a more formal way. It can contain boards that have slides that curate and synthesize the progress work, as well as final drawings, layout boards, slideshows, video recordings of the project, and basically interactive map of how they want to tell the story of their project. Since the virtual whiteboard application like Miro can handle many types of digital media files and presentations, you can have a much richer format that can both be delivered directly by the student, whether through a slideshow or in the Miro application itself, but also offer a map for discussion that keeps everyone more engaged in the actual details of the project and allows them to zoom in and out and understand what's really going on much quicker than when presenting through a projector over Zoom through only slides or even on a wall pinup format. This is similar to the formal pinup wall in a physical studio space. Work is curated and formatted to the presentation for a formal discussion, but students can guide the viewers around the virtual wall in Miro, and viewers can explore the work on their own at many resolutions. The virtual space also allows an easier sharing of interactive digital content such as GIFs, videos, AR and VR content and models, and PDF slideshows. One key advantage to the virtual space is the ability to zoom in and out for greater clarity and perspective on the project's assets. Developing online courses is closely related, and the success is dependent upon the platform one chooses to work with. We discovered that the infinite whiteboard space of platforms such as Miro provide the opportunity to collect all relevant teaching materials in one place with one URL. This means that students have access to everything all at once, and all they have to do to access it is log in. The history of the course is laid out before them, they know where things are going, and they can reference anything that's been done or said relative to the work right there anytime they need to. This kind of codifies the desk-grid system and keeps things that normally get lost, shuffled around on the desk, or dropped on the floor in one space until a need for curation arises. This diagram shows the course structure that we developed for kind of a basic studio environment. The colored columns indicate the different types of course content we include in the Miro environment. This space is structured such that the different types of teaching materials are organized left to right and in the columns that are organized. The first column includes the course syllabus and the breakdown of the weekly rhythm. It is possible to add evaluations, criteria, as well as updates to assignments and more detailed weekly instructions on the fly or before the studio starts. The second column shows the weekly schedule. It is possible to link the calendars or simply make them inside of the Miro environment. And the third column includes all resources that may be needed to present additional material for the course. The last and most expansive column is populated with the student work and is aligned with the bi-weekly or weekly schedule of assignments. But we see that there's a lot of flexibility here, and we've tried many different formats, whether that's kind of a linear column format, a more desk space individual student format, group collection formats. This area becomes kind of flexible depending on how and what you're teaching within the studio course. And that speaks a lot to the techniques and methods of how and what we are teaching and what we need to build up as a kind of foundation for online students to be able to communicate effectively and operate at that same level that often happens organically in person. We see this taking place around representation or sharing many mediums online, as well as making at home, and that material geometry systems can lead to more formalized design strategies. We'll begin with the remote representation and the techniques that we can build up through exercises while designing to help students succeed. In this case, they're kind of broken down into the different mediums or formats that might be explored in some design or art studio. We have kind of 2D to 2D workflows that change digital analog flat work, such as drawings, paintings, collage, things that are produced physically and maybe done by hand, into digital artifacts that can be discussed with enough clarity for overview. And just with a little bit of setup, you can help a student develop a photography sequence with basic room lighting, day lighting, and a phone and a tripod stand that will lead to consistent results so the work isn't distracting because of the informal nature of the photographs, and it also helps them later for documentation in their portfolio. Similarly, for 3D work like models or sculptures, design studies, we can translate that to a 2D medium such as photography or video by, again, developing at-home photography setups using things as simple as a sheet of Bristol paper, a wall background, a few desk lamps, a phone on a makeshift or purchased tripod, depending on the scenario. And with an understanding of some of the basic techniques for framing, establishing views, setting up perspective, and even moving the camera relative to an object, it allows students to quickly tell the complete story of what they're working on, even without being able to hand it directly to a critic. In the 3D to 3D modes, we can take things like study models and use the phone or a camera to scan them using photogrammetry techniques and then share them on platforms such as Sketchfab or other VRML platforms where the work can be uploaded and embedded in the Miro interface and then opened by a remote observer, panned around, zoomed into. You can play with materials and lighting effects and really start to have that handoff experience of a study model, physical study model. Or if the models become digital, not working in an analog workflow, similarly, you can upload those to the kind of sharing platforms like Sketchfab, or you can use things like Enscape or Keyshot to provide kind of VR 360 camera renderings that can be viewed on a web page and again, embedded in the whiteboard environment for view on the remote end. And we can even go so far as starting to employ things like video game engines for crafting 3D experienceable worlds and sharing those through websites so that any critic or viewer can be in single or multiplayer environments and explore the works of architecture or design, kind of in that immersive state that's almost transcending something that we can do in person, which is just construct this at a full scale, which is very challenging. And here we can start to experience it, at least at that scale, depending on the level of detail in the project. And one other very useful aspect of this is teaching representation techniques about how to document progress work so that you can have some interface into how the student is working, which can be very helpful early on or with new techniques to guide their hand in a sense. And we find that very valuable for them to just point it at their workspace, record in a time lapse what they're working on, and share that with us so that we can understand how they're working and help produce better workflows if necessary. And the following is just some examples from each of these segments, kind of looking at quickly how we are structuring this guide around producing this consistent result. Some of the drawings there on the left are from first year representation students in their first semester in college in an online course, and able to get like a general consistent result that allows us to see the work and the quality level we need to review it. It also focuses some on the production of digital assets in a second semester, first year course of being able to output, properly resolutioned PDFs or images that share well on the platform and are interactable and help the students to receive feedback. In the Inverted Studio, the camera is a key interface for representing the digital and analog design work. It is critical and simple to introduce basic techniques and methods of still photography and videography to help students see their work and to communicate through the screen. We produced several guides and tutorials on how to set up a very basic photography setup at home, and then to utilize the fundamentals of those techniques anywhere. Some of that goes as simple as just how do you frame the view of an object to give it presence? Are you talking about it as a model, in which case we see it on the desk, or are you trying to describe it as something with scale and space around it, and you can control how the camera is placed next to it to help us feel that interaction and really communicate an idea about the design. The lightings, environments, framing, positioning of an object relative to the camera is really the primary interface for establishing scale and guiding the attention of the student and faculty. Photographs can calibrate and communicate the idea of design discoveries and rapidly see the object in many different scales or contexts. This is something that's both valuable for the longer term goal of communicating design, but also really critical to working in the online environment, since it's your primary exchange through that screen interface is capturing the photograph and going beyond the very casual documentation of I did a thing to the communication of what you've done with that thing. Many of the disciplines at Pratt rely on the interaction of physical 3D mediums as part of the design process, and then finding a way online to share those and provide the same level of feedback is one of the main challenges we explored in this. And we feel that through some basic training in the photography, we're able to get to a point that students' communication can clearly convey what they're trying to do and start to let things leap beyond in both a analog and digital format, the looking just at a model, and start to move into the space of being a proposition for, in our case, architecture, but any type of design. And it's not so complicated for a student to create a basic at-home photography setup. It could be even included in kind of a first semester kit for an online program, and really requires kind of a basic tripod, some good desk lamp, diffuser lights, and then some kind of backdrop that can be set up consistently and like rolled up and taken down to not invade too much of the space in the at-home environment. We also think that moving just beyond still photography and into some degree of cinematic or videography can provide a lot of new ways to look at the work and really understand its more spatial or three-dimensional context. That could be anything from the basics of panning, dollying, zooming, or orbiting to engage with specific aspects of an object or of a design proposal, or seeing it in a more documentary fashion of giving us a 360 kind of orbit around it so that we can understand its full context very quickly. This works in both the analog by using a phone or digital camera, but also in the digital space by using rendering engines that allow for some degree of camera animation. And these can be picked up pretty quickly. The techniques are transferable since both the analog and digital are based on the same general principles about how to control a camera and mediate that interface between what is seen and the viewer. In many of these cases, since our students went online very quickly and didn't necessarily have this equipment set up, we would encourage them and guide them to make very makeshift setups. You can use kind of some pieces of foam core, blocks of foam, or chipboard to create a nice series of small stands for your camera phone, and then even produce things like Lego wheels to create dollies or zooms, or to be able to track around an object. Many students were able to make at-home tripods or turntables to further animate this process of seeing through the cinematic lens of the camera. So we see the moving image as being a very effective way to communicate about three-dimensional space and objects, and it introduces the time format that lets them start to communicate a story. Videos of the physical models together with digital animations can convey very different aspects of the same design, and we encourage students to practice both techniques and find the overlaps and also differences between them. The ubiquity of mobile phones and high-resolution cameras, as well as open-source software, provide new access to techniques of digital scanning of physical artifacts. In this case, we can use software like Metashape or Agisoft to take a series of photographs in any environment and translate something made physically, something found through the design process, into a digital artifact that they can be further explored for materiality, lighting, scale, and context, or even interaction with the human body, placed into VR environments and explored for its potential as a design artifact, and then remodeled and translated into full-scale production concepts and fabrication setups. This can work also with platforms like Sketchfab, where you can take a model, whether digitally modeled or scanned, and just hand that through the digital interface through a link to a website to a reviewer that can explore anything from a small design of, say, a shoe or a study model to a full building by zooming in and out and turning on lighting and material effects. Even beyond the Sketchfab environment, there are kind of platforms like Keyshot, Enscape, or Twinmotion that can generate kind of a website of pre-rendered images that have a high degree of control and resolution for a student to share a kind of embodied spatial context that can be opened on a phone, a laptop, or placed into a VR headset for a curated experience of a design proposal. Kind of at the extreme end of technical ability, we were able to introduce the use of video game engines with some of our advanced studios, where templates or drag and drop platforms built by Unity and Unreal for video game engines can take the same geometry, either scanned or modeled by our students in architecture, and place that into an interactable environment so that reviewers and critics or the faculty can come into the space, walk around, move around, see the things happening, and really experience what the proposal is for the project with things like dynamic lighting, collision interaction, and even putting stuff into kind of a virtual gallery context to have a review in real time, in real space. In our second studio, we even went as far as make this environment multiplayer so you could see where people were at. You could move to the same thing and point it out with your avatar and be able to have a discussion like this was built at the school. Again, with all of these basic techniques of photography and video and the access to our personal phones and being able to do time lapses, you can really communicate a lot about the construction of and working through material processes by sharing time lapses and recording that into a format that is easy to upload, whether that's images or an animated GIF or even just a video hosted on a platform like YouTube. Next really important part of this kind of transition to the online space is to help make a strong connection between the material ways of working and designing and the outcomes that we have access to through both large-scale industrial production processes as well as at-home on-the-desk things, as simple as Bristol board and a cutting mat, to using a desktop paper cutter or 3D printer, or getting into material translation methods like casting and vacuum forming. So similar to the representation, we're really thinking about this in like kind of 2D and 3D formats. For materials, there are like the more accessible, perhaps two-dimensional kind of material methods that go from the simple folding of planar sheet material, polyhedrals, and things that can be scored on a flat piece of paper, folded to make a cube or any other flat planar form, to curve folding, getting slightly more advanced using techniques of curved crease origami to make more complex shapes, moving into kind of contour crafting of solids with a desktop paper cutter similar to a laser cutter. You can take a solid volume and begin to break it down into slices and waffle structures. And we even went so far as having a student develop their own at-home vacuum forming machine from some old parts around the house. It would allow them to turn flat plastic sheet material through heat and vacuum pressure into a three-dimensional mold or panel system. On the three-dimensional material method size, we have 3D printing. Many students have them, and they're generally quite inexpensive these days to be able to get up and running. So it could be something as part of like the general material kit for a program with an online studio system. We also really encouraged experimenting with materials, since you could go out and find things around you for doing casting, dyeing, translating of things made in a very abstract way, like the 3D printer or folding, into stuff with more concrete consequences. We're also really interested in kind of priming students for some of the techniques for the systems that they might only really have access to in short time periods in person, such as robotics carving systems. And using hot wires to send foam, we could do ruled surface carving that scales up very quickly from something you can do at your desk to something you can do with a robot in a large lab, and allows the students to start to make things with multimodal materials like solid foam and linear stick elements that approaches an architectural tectonic quite quickly. And then we like to look into kind of analog sculpting techniques as well, stuff that could be used across disciplines, but in architecture you might cut, carve, glue things together, and then find ways to translate those to the next medium. This series of quick slides look at each of these categories to demonstrate some of the variety, difference, and ways of working that our students developed over a couple of semesters to use these techniques to go from like very small kind of study model scales into much larger propositions and architectural design proposals. So here we see in a planar polyhedral folding using things like Bristol paper, chipboard, which translate up to plywood and aluka bond in an architectural sense, to think about the ways things are made at the small and the large as they are designing. So this understanding of material geometry and its fabrication consequence all being tied together in an exercise that's very digestible for many age groups. Anyone from a high school student or younger up to our advanced studio students can work with these techniques to get something that can be physically made and designed for real life interaction. Similarly, the curved crease folding that my partner here at the DRA, Koschitz, has a lot of expertise in, is something that can be done both analog, fully exploration through just how you draw a crease and fold the paper, or digitally translated from a Rhino model and reflection of cylinders and cones into physical models quite quickly through unrolling and developable surfaces, that teaches the students about that reciprocity between analog and digital that lets them really simulate a material consequence that has design outcomes as well. And you can get quite complex pretty quickly. These are all examples from short 1 to 2 week exercises that students would perform in our studio during the summer. We can also go into more kind of complex and advanced curvature. The 3D printer allows for this like generally kind of limitlessness of translation, but also provides this artifact physically for the student to engage with, to draw on, to cut, to add to or augment, to take it beyond the monolithic output of a plastic printer into a design tool that then can be fed back in either through their digital model or through scanning or some combination of both to continue to drive the design forward as a way of making that might scale eventually to large-scale 3D printing. Or in the case of using sheet goods again, we can develop these three-dimensional forms as contour crafting methods. The 3D printer essentially being a contour crafter at a very fine scale. We can use paper or plywood or other flat sheet material to craft at a more coarse scale by producing layered models, waffle structures. And this often allows us then to mix in other mediums such as casting of plaster, concrete, using silicones, providing dye and texture, color to really simulate some of those materials that students might want to apply at a larger scale in architecture, but be able to do it at their desk at home with just a few supplies, a small pan, protect the area, and change the way they start to see materials impact on their design, which is really important next to something like 3D printing or using the abstract of chipboard, that it can get a little bit lost of how that scales up to the real. And so we like to keep some of those materials at play. And we can even look at these larger scale industrial processes as one of our more ambitious students who had been in person and was exposed to the tools we have, such as our large scale vacuum formers for making molds and panel goods, took it upon themselves to deconstruct an old toaster oven, use the family vacuum in the garage to heat up a few sheets of test it out, and actually achieve fairly reasonable results for a small scale thing at home. One of the ones I've found most interesting in the translation between large scale fabrication techniques with emerging tools like the robotics and something that a student can do for $30-$40 at their desk is to use ruled surface carving of large monolithic foam blocks and find ways to translate those into architectural propositions through sticks for following the curvature and linear elements for assembling them together. They're also great for just quick design studies and form explorations. And we always think it's useful to have more openness in the design process and leave some times for free expression and starting to combine things, playing with using malleable materials, in a sense kind of like plaster casting or paper mache, carving objects and then covering them and sanding them and changing their material qualities, 3D scanning them, or working with anything that they can find around them if they're kind of in a position not to be able to get material, as many of our students were in the pandemic context. And that hybridizing of materials is where we see all of these techniques coming into play in the greater design context, that these are just things to learn, to know the ways to interface between the digital and the physical space. And once they've tested many of them out, they can begin to choose the ones that work for them and for the project they're beginning to propose and find ways to bring them together, as most architectural or other design projects have to use many forms of geometry and materiality to craft the thing that we will interact with eventually. So again, the final aspect of this is promoting not just a technique-driven studio context, while that is very important to understand these techniques of representation and of material geometry interfaces, but by hybridizing them on both fronts in mediums and methods to use that to find new approaches to actually constructing a project proposal for any kind of design scenario, architecture or otherwise. So these are just a few student projects that really exemplified that they can get just as far as our in-person students and be prepared from a 15-week or 16-week studio to go from small scale representation and design studies to having a full documentation set of a project that could be built or tested as a fabrication prototype. So this blends things here like model photography. This is a pretty large 1" = a foot scale model using cone ribbons and casting as their primary material methods, but really breaking that apart into the details, the attachments, the way geometry flows into material, going through several rounds of iterative study models and prototyping, and getting down to where you can fully document a set of kind of exploded blueprints for sharing how this thing is going to be made or translated to that next step of architectural implementation. And the student then can communicate kind of all layers of that process, whether it's the constructing of the forms, the crafting of the molds, the translation of material, the spatial experience through a phone camera and careful calibrated camera movements, or the inhabitation of their project in a real space as a proposal to install this when provided the opportunity back in person. Some of the simplest techniques can still lead to very complex and refined results. This again is a photograph of a physical model made at home by a student in our summer studio, looking at primarily planar and curved folding. They had an interest in combining the kind of sinuous-like nature of curves and the angular nature of the folding to produce this pavilion that could kind of move around and envelop. It passed through many iterations that learned from all of the techniques they explored in these shorter exercises, but focused them into one or two ways of working with material that would allow them to get the closest to the formal ideas they might have discovered by 3D printing or foam carving, but build in a very kind of rapidly iterable way through CNC paper cutting with their desktop paper cutter at home. And students can really push these techniques quite far when working just with their desktop space. Here we see some analog animations of this model produced to exhibit a project that looks both at curved crease folding again to give very rigid structural surface elements, as well as vacuum forming or print forming to have a more organic feel to the project. And the students able to produce all of this, in this case, actually without 3D printing, by making their at-home vacuum former and really controlling the geometry and material aspects of what they were designing, both in analog and digital means. Here again, the project goes through many iterations over this course, and the really embodiment of the practice of technique, both for communicating and designing, can be put together into this hybrid structure that transcends any one of the specific elements of the geometry, the material, or the representation, and becomes this whole project proposal, which again is just evidence that we're not losing the access to these ways of working, both analog and digital, by shifting to an online platform, and can keep all of it live so that students understand, in a context of something like architecture, that they're able to manipulate material in the physical world at the large scale that is necessary for architecture, but still practice that wherever they may be, since that's not much different than how they might operate in a small office context or in some of our remote working environments already in place around the world. And this was the student who invented their own vacuum former, and also in their spare time and working as a research assistant, brought that together into a small guidebook to share with others that any other student could see. This is how I made it. These are the things that I had around, and you might be able to find alternatives and get decent results with something quite simple and ingenuitive. And we have a whole lot of examples from other students across that studio that was taught in the summer of 2020 and another one in the fall of 2020, kind of almost repeating the same process with small tweaks and testing out different methods of documentation, starting to play with different ways of formatting the course schedule around this core kind of fundamental template to see if group projects could work as well as individual projects. So we see the inverted studio not as a challenge or something to shift away from some of the necessary traditional analog methods of understanding how material works with form in the world to create things like architecture, product design, or art, sculpture, painting, but to embrace them and teach them at a new fundamental level that doesn't necessarily rely on all of the resources of the Institute, but can translate it to kind of the need for ingenuity and creativity for a student, and prepare them for when they do have access to those resources, that they can fully utilize them and scale up their work to that more productive level. This also is very important in the context of kind of a large student body like we have, that many of our students may not have access to our production facilities because there's just simply so many of them that it's a kind of bottleneck for that. But if we can kind of provide these guides and then the recommended tools that are fairly accessible financially to most students, or even provide them for kind of smaller groups of students to use, Like we've tested out buying these paper cutters for kind of each studio environment or 3D printers for multiple studios. And then the students can get hands-on experience with these techniques that eventually scale up to produce larger constructions and help them understand that interface between what is so much a primarily digital workflow in the architecture design professional practice and the real material outcome that is the actual consequence of that architectural design. Thank you for having us. You can check out some of the work we do with geometry and materials at the dra.pratt.edu. I'm Robert Brackett. My partner, Koschitz, who is the director and founder of the DRA, was also co-participant in designing these studios and testing stuff out with the students. Again, I'll thank our TAs, Noah Rosenberg and Daniel O, and all the students that went through this experimental process with us and really and have pushed themselves to find out what they could do differently at home, how they could communicate in this new platform that they were all forced into in some sense, and take out of it something very productive that will serve them for the rest of their careers. You can reach us at the DRA at dra@pratt.edu, or my email address at Pratt is rbrac131@pratt.edu. You can find my other professional work at Digital Nouveau and miscellaneous projects. Thank you, and have a wonderful day.